your notes for section 8.1.4 are really just some practice problems working back and forth with all of the formulas we've been learning for interior and exterior angle measures in a polygon. So I just want to review a few with you right now. Remember that the sum of the interior angles of any polygon, whether it's regular or not, can be found by taking the number of sides and subtracting 2 and multiplying by 180. Okay, so this is for any polygon. As soon as it becomes a regular polygon where all side lengths are the same and all angle measures are the same, then we can start figuring out what the measure of each interior and each exterior angle is. Okay, so for a regular polygon, each interior angle is going to have a measure of n minus 2 times 180 divided by n, because we can take the sum of all the interior angles and divide it up evenly among the number of interior angles because they're all the same measure. And again, if we have a regular polygon, each exterior angle can be found by taking what we know to be the sum of the exterior angles of any regular polygon, which is 360 degrees, and dividing it by the number of sides and angles, which is n. What I'm going to do is go through some of the problems on this notes worksheet in this video, and then I'm going to stop and give you an opportunity to try some of the other problems as practice. The answers to those problems will be in a second notes video for you. So we're going to start with problem number 36 from your book. How do we go from knowing the number of sides to the measures of the angles? How do we work back and forth between those two values? If we know the number of sides of a regular polygon, how can we find the measure of an interior angle directly? And notice it said regular polygon, so that means all of the sides are the same length and all of the angles are the same measure. If we know the number of sides, we can take the sum of those interior angles and divide it by n, which tells us the number of angles we have. Remember, that means we're taking the sum and splitting it up evenly among all of those angles. We find the sum by taking n minus 2 times 180, and then we divide it up among all of those angles evenly. So if we're asked to find the measure of each interior angle of a 15-gon, a 15-sided polygon, we're taking 15 minus 2 times 180 to find the sum of all of those interior angle measures, and then we're dividing it by 15 because we're splitting that sum up among all of the angles. Okay? In the numerator, the sum of the interior angles comes out to be 2,340. Divide that up evenly among the 15 angles, and each interior angle has a measure of 156 degrees. What if we know the number of sides of a regular polygon? How can we find the measure of each exterior angle directly? Well, remember, the sum of the exterior angles of any regular polygon is equal to 360 degrees. They all have the same exterior angle sum as long as they are regular. So if we take those 360 degrees, divide it evenly among all of those exterior angles, we will have the measure of one exterior angle. So if we're asked to find the measure of each exterior angle of a regular tengon, a polygon that has 10 sides, we know that the sum of those exterior angles is 360 degrees, and we're going to divide it evenly among the 10 angles. That means each angle is 36 degrees, each of those exterior angles. What if we know the measure of an interior angle of a polygon is 162 degrees? How many sides must that polygon have? Well, let's think about how we found the measure of that interior angle in the first place. It is a regular polygon, so all of those interior angles have the same measure, okay? We found the sum of those interior angles by taking n minus 2 times 180, and then if we took that sum and split it up evenly among all of the angles, we would find the measure of one of those interior angles, which we know is 162 degrees. We're taking the same process that we used in part A. Our unknown is just different. In part A, we knew what the value of n was. We did not know what the measure of each interior angle was. In part C, that flips. We know what the measure of each interior angle is. We don't know the value of n, or the number of sides and angles that this polygon has. So we're just going to solve this problem now. What we're going to need to do is cross multiply to get rid of n being in the denominator of that fraction. I'm going to cross multiply and distribute at the same time. If I distribute the 180 to the n minus 2, I have 180n minus 360, and that is equal to 162n. If we continue to solve this equation, we're going to subtract 180 from both sides, so negative 360 is equal to a negative 18n, and dividing by negative 18 tells me that n is equal to 20. So a polygon that has interior angle measures of 162 degrees has 20 sides. What if we know the measure of an exterior angle of a regular polygon, and again, regular, is 15 degrees? How many sides does it have? Well, again, we want to think about where that measure of 15 degrees came from. It's an exterior angle. That came from taking the sum and dividing that sum evenly among all of the exterior angles. Again, same process that I used in part B, my unknown is just different. In part B, I knew the value of n. I was looking for the measure of each exterior angle. In part D, I don't know the value of n, but I do know the measure of each exterior angle. Now I'm going to cross multiply to solve this equation. 15n is equal to 360 degrees. When I divide by 15, n is equal to 24. So a polygon that's regular, that has exterior angles of 15 degrees, has 24 sides. And finally, what is the measure of each interior angle? Well, if I know the measure of each exterior angle is 15 degrees, let me just draw, what if this is one angle in the polygon? Okay, and the polygon's continuing up here. Here's the exterior angle of 15 degrees each exterior angle forms a linear pair with each interior angle. So if I know the exterior angle is 15, the interior angle is just 180 minus 15 degrees, which is 165 degrees. Here we have a situation where we have a regular polygon that has one interior angle measuring 120 degrees. How could we find the number of sides using two different strategies? So before, on the first page of your notes, we talked about how that 120 degrees, the measure of one of those interior angles, came from taking the sum, n minus 2 times 180, and dividing it evenly among the number of angles that we have, or n. And so you could go ahead and solve that equation. So this is just like problem number, let's see here, 836, letter C. Okay, it's just like that problem. And so we could go through and solve this. I'm going to cross multiply. 120n is equal to, and I'm going to distribute as well, 180n minus 360. And if you solve this equation, you're going to find that n is equal to 6. The number of sides in that polygon is 6. But we can also think about this in terms of the exterior angles. Let me draw you a little picture here. If we have a polygon that has an interior angle of 120 degrees, that means it also has exterior angles that are 60 degrees. And so we can also use that exterior angle measure to help us find the number of sides in the polygon, which is exactly like on the front side of your notes, problem 8-36, letter D, the first part of letter D. Okay, if each exterior angle is 60 degrees, we know the sum was 360, and we divided that sum by the number of exterior angles to find that each exterior angle was 360 degrees. So we can also solve this problem by solving this equation. If I cross multiply, 360 is equal to 60 times n, and when I divide by 60, I still get that the number of sides is 6. So we can use either method. Which strategy is more efficient? Well, strategy number 2 has less work for sure. Which one you use really depends on which way your brain processes it best. What I'd like you to do right now is stop the video and work through the practice problems on the bottom of this worksheet. If we were in class, I'd have you work through these as a team. I will post a second video that has the answer to these problems and also the answers to the problems on the practice worksheet that I posted this week.